Welcome to discussion 28. In today's discussion, we'll focus on sections 5.1 and 5.2 on definite integrals. In this video, we will take a definite integral of a piecewise function. This is problem number 10 from worksheet 13, where we have this function f of x, which equals negative root 4 minus x squared plus 5 if x is in between negative 2 and positive 2, and it equals negative x plus 7 if x is greater than 2 and less than or equal to 8. So we want to find the integral from negative 2 to 8 of this function. So right now, we know two ways to evaluate definite integrals. We could either use a limit of Riemann sums, and that's typically very tedious, and it works best if we just have low degree polynomials, and with this function we have a square root of something, and that's looking like not something that we typically would do a limit of a Riemann sum with. And the other way that we know right now to handle definite integrals is to think about them as areas. So if the graph of our function is simple enough, so linear or circular paths, then using the area approach can be helpful. And for this particular piecewise function, each of these pieces has a nice shape. So I first want to give you 4 minutes to try this. So pause the video in 4, 3, 2, 1, pause it, and try it for about 4 minutes. All right, so hopefully you did that. Hopefully you paused it and tried it. Let's talk about it together now. Okay, so let's focus on the top piece. So I'm going to start with a graph of just y equals the square root of 4 minus x squared. So 4 minus x squared. So we saw in lecture what the graphs of functions like this look like. This is going to be a semicircle that's centered at the origin, and the radius is going to be 2 because this 4 represents r squared. So we're going to go 2 units to the right and 2 units to the left. And then if I think about, well, what part of the semicircle is it? Is it sort of like the upper part or the bottom part? When I take the square root of something, the output will always be a non-negative value. So these y values are going to be non-negative. And that means it's the upper part of our circle. So not the full circle, just the upper half where the y values are non-negative. So this y value at the top is going to be 2. Okay, but we have a negative sign in front of the root. And putting a negative sign in front of the root will reflect the graph across the x-axis. It'll change the sign of all of the y values. It'll make all these non-negative y values now be down here below the x-axis. Okay, so if I draw my axes now, our graph is going to get flipped across the x-axis. So this is 2, negative 2, and this is going to be down at negative 2. And then finally, let's add 5. And if I add 5 to my formula, that's going to shift my whole graph up 5 units. So this is 2, and this is negative 2. Now this whole thing has gotten shifted up 5 units, and it looks something like this. So this, oh, let me draw that better. It's got to be the same height, 5, and this y value used to be at negative 2. It got shifted up 5 units, so now that's at 3. Okay, so that's what one of the pieces is going to look like. All right, the other piece, the negative x plus 7, I know that that is linear, so that's going to be easier to draw. Let's put it all together. Let's draw y equals f of x. So I'm going to zoom it out a little bit. Okay, and I'm going to make some axes. So make some axes, and I'll label negative 2 and positive 2. And on the interval from negative 2 to positive 2, our piecewise function is just this semicircle graph. So it's this upside down semicircle with this y value is at 5, and this bottom part of the semicircle reaches 3. And then I shift to this negative x plus 7 graph. Okay, and I start that graph sort of when x equals 2. So with y equals negative x plus 7, if x equals 2, and I were to plug that in, we get y equals 5. Okay, so that would correspond to this point where x is 2 and the y value is 5, which is already closed. So because I don't have an equal sign here, when I start to draw this piece, I technically would have had an open circle drawn there. But because there's already a closed circle there from the top piece, it's just going to pick right up from there. And I know my graph, this portion has a negative slope, slope of -1, which is why I'm going to make it go downwards. Okay, and it ends when x equals 8. If I plug an x equals 8 into this, we will get that y equals -1. And because the equal sign there, we do have a closed circle, and this y value we now know is -1. So we want the area of the graph, well, the interval from -2 to this is 8. Okay, so I'll draw a vertical line here. Okay, and I'm going to draw one more vertical line at 2, because now this splits up my graph into a bunch of nice shapes. Okay, so I'm going to call this region A1, this next triangle A2, and this tiny triangle over here A3. Alrighty, so I could find the x-intercept of this graph pretty easily, and it turns out that x-intercept is going to be at 7. Okay, so now we are ready to evaluate our definite integral. So from -2 to 8 of our function, remember, when we evaluate a definite integral, it represents a signed area. So the regions above the x-axis, like A1 and A2, they get counted as positive areas. So I will add them together. But when there's a region like A3 that's below the x-axis, that gets counted as a negative area. So we're going to subtract the area of A3. Okay, and I'm going to hold up, well, actually no, let's do A1 first. So A1, if I focus on that region, it looks something like this. And if I draw another line here, I notice that this is just a rectangle. This is a big rectangle with a height of 5. And this base is 4, because it goes from -2 to +2. And I'm subtracting away this semicircle. So for area 1, we got to do the area of that rectangle minus the area of the semicircle. And then for area 2, that's a triangle, so I'll do 1/2 base times height. The base is from 2 to 7, so that's 5 units. And the height is also 5. And then I do minus the area of this small triangle. So again, I do 1/2 base times height. The base of that triangle is 1. And the height, because this y value goes down to -1, that height is also 1. Okay, so rectangle area. Well, that's going to be 4 times 5. The semicircle is 1/2 pi r squared. And the radius of this semicircle is 2. Then we'll get plus 25 over 2 minus 1/2. Okay, and if I simplify this, the 4 times 5, and then that becomes 20, and then 25 halves minus 1/2, that becomes 12. So 20 plus 12, that is 32. And then this 1/2 pi times 2 squared, that becomes 2 pi. And that is our answer.